Okay, so today we will continue the topic for two sample problem. Okay, so two sample problem is just like compare two classes or compare two different methods. Okay, so we say for those two sample problem, we usually convert those as a testing problem. So HO is equal mu1 equal mu2. So HA, we have three options, right? Can be larger than or less than or not the same. So which one we should choose just up to us. Okay, up to, so depends on what is our purpose, right? So we say under HO, we have this. We say this thing follow normal. Okay. So this thing follow standard normal. Okay. But the question is, we don't know sigma 1, sigma 2, right? So if we replace sigma 1, sigma 1, sigma 2 by S1, S2, we then have this test statistic. Okay? This test statistic. So x bar minus y bar, so S1 square over N1, S2 square over N2. So for this test statistic, we want to determine this big or small, right? So we have this number, then instead we just needed to determine this big number or small number. If this big number, then we say our difference is big. If this small, then difference is small, right? Okay, so how can we determine this big or small? We need to compare this number, this test statistic, with some critical value. So where we can find a critical value? So this is the problem, right? So which table we should check, or which distribution these things follow. So we say this test statistic roughly follows this T distribution with the degree of freedom is this. So this degree of freedom is also roughly. So here we have this question. Now, in which case we can have a precise distribution for this test statistic. Okay. Okay. So in which case we can have a precise or exact distribution. Okay, so let's say that the problem is we just replace two sigmas, right? We say like let's review. If we replace one sigma by S, then the Z distribution or standard normal become T distribution, right? So if we replace this two sigma, sigma 1, sigma 2 by S1, S2, then we have some trouble. Okay? So now let's consider this. If we there's two sigmas, essentially we have one sigma. So if the sigma 1, sigma 2 actually is only one sigma, these two sigmas are equal, then we have this. We can, let's say, so x bar minus y bar. So here sigma 1 square over n1 plus sigma 2 square over n2. These things follow standard normal. Okay, right? So if sigma 1 equals sigma 2 equals sigma, then we can take this sigma outside. So we have this one, right? We can take this sigma outside, okay? So we say this follows standard normal, okay? So even though we know, we assume sigma 1, sigma 2 are equal sigma, but this sigma, we still don't know. So even though we say the 2 sigma essentially have 1 sigma, but this sigma we still don't know. So how can we replace this sigma by a's? How to replace this sigma by a's? So here we have 2 a's. Like we have s1, s2. So if we replace sigma by s1, so other people will ask, why not S2? If we replace this by S2, we will ask, why not S1, right? So we simply cannot replace sigma by S1 or S2. So by what? So here I will introduce this notation. Poured standard deviation, which come from poured variance. So what is poured variance? So poured means put together, right? Poured is just put together. Put together, we have poured. Okay. So we define this poured variance is a weighted average. So poured variance is weighted average for those 2 variance. Right. We have S1 square, we have this variance, we have S2 square, we have 2 variance. Then this poured variance, so we denote this as a SP poured variance. This is weighted average for these 2 numbers. So here we explain this weighted average. Okay, so before we talking about average, is just add them up, divided by 2, like, or divided by n. So like, let's say, like, so here we have 2 numbers, 10 and 20. So what is their average? So we say, oh, easy, we just add them up, divided by 2. So for this one, we can write this as half times 10, right, plus half times 20. So we can regard this half as weight. So we weight these 2 numbers equally. Okay. So in general, we can not weight them equally, right? Let's consider this problem. Like we want to find weighted average of these 2 numbers, weighted on 2 and 3. Like so, 20 weighted 3 and 10 weighted 2. So this average is like the 10 weighted 2, but the total weight is 5, right? So average should be like this: 2 over 5 multiplied 10 plus 3 weighted 30. Oh, sorry, here 20. Okay, saying divided by total weight 5. So this is the weighted average. Okay, so we can say the poured variance is also weighted average, but weighted on what? Weighted on the degree of freedom. On degree of freedoms. So let's say like here we S1 S2 square. So S1's degree of freedom is N1 minus 1. Okay, and S2's degree of freedom is N2 minus 1. Right? Degree of freedom is N minus 1. So here n1 minus 1, n2 minus 1. Then total weight, you add them up. n1 minus 1 plus n2 minus 1. So here is also like a total weight, n1 minus 1 plus n2 minus 1. Okay, so this is polar variance. Okay, so we say a weighted average is very common actually, not only in statistics, in many problems we should consider weighted average. So for example, like let's say here we have two classes. Class 1's average is 80, class 2's average is 85. Then we want to find what is the average for all students. If we put the two classes together, what is their average? So this average we cannot simply add them up divided by 2, right? Because the class size not the same. So actually the average for all we should do this way, like equal like let's say, so we can like put so average equal total points divided by total students. So here total students is 50, right? So 20 in class 1, 30 in class 2. So here should be actually, so total points in class 1 is 20 multiply 80, right? Then total points or total scores from class 2 is 30 multiply 85, right? So this one we can write this as 20 over 50 multiply 80 plus 30 over 50 multiply 85, right? So we can say this average is the weighted average for 80 and 85. So weighted on what? On the number of students, right? Okay. So here the same problem. If we have 3 classes, these 3 classes, the average is 80. Class 1 is 80, class 2 is 85, class 3 is 90. So what is the average for this? The average for the 3 classes. Okay. So this average we also should consider the weighted average, right? 80. So weighted on the number of students. So here this class 1 students is 20 students in class 1. So plus, so for class 2 we have 25 students. Class 3 we have 30 students. Then total students, add them up, is 75, right? So this average for all should calculate this way, right? Average for all should calculate this way. Okay, so now we understand the weighted average. Weighted average meanings, right? So now let's consider the problem. So we consider this problem before, like we have 2 classes. Class 1 average 84, class 2 average 81. So we have evidence that 84 larger than 81. So we have evidence that the class 1 perform better. But we need to check this, whether this is significantly better. Okay, so for such a problem, so we say this is a high power testing problem. Like it shows mu1 equal mu2, no difference. So HA, we wanted to prove, so HA we put mu1 larger than mu2. because our purpose is I wanted to say mu1 this class 1 perform better than class 2. Okay, so then for test statistic, so this time we assume variance equal variance. So sigma 1, sigma 2 equal, so we have 1 sigma. So we, let's say, saying this test statistic formula is thus x bar minus y bar. So over so we can replace sigma by SP. This poor standard deviation. Okay, so 1 over n1 plus 1 over n2. Okay, so we should use this as a test statistic. So in order to apply the formula, at first we wanted to find a pooled variance. So we have two variance. So standard we have two standard deviations, 5 and 6. So variance is just square, right? So we have two variance. One is 5 square, or 25. Other one is 6 square. So the pooled variance is the weighted average for those two numbers. So weighted on what? On their degree of freedom. So this is 5 square. This variance, the degree of freedom is n minus 1 is 24. 25 minus 1. So this is a degree of freedom 24. And this one degree of freedom is 19, like 20 minus 1, 19. Okay, 19. Then total degree of freedom 24 plus 19 is 43, right? So 43. Okay, so use this formula. So we can find this is pooled variance equals this thing, SP equals this, pooled standard deviation equals this. Then we plug in this formula. So we say x bar minus y bar over SP, 1 over n1, 1 over n2. So plug in here. X bar is 84, y bar is 81, so SP is 5.46. Take square root of 1 over 25, 1 over n1, plus 1 over n2 is 20, right? So after a little bit calculation, we find this number is 1.83. Okay, so this is our test statistic. Okay, so then we want to determine, we want to check if this number is a big number or small number. So we need to find critical value. Okay, so here this critical value is T critical value. So we need to check a T table. So for T table, at first we need to determine degree of freedom. Okay. So degree of freedom is n minus 1. This is for one sample. So this degree of freedom is, we say actually degree of freedom for variance for a square. So we have this formula, right? For one sample problem, xi minus x bar square thing over n minus 1. So this denominator is degree of freedom, right? So here the degree of freedom is the degree of freedom for these things. This is pooled variance. So for pooled variance, the denominator is 43. Like this is the degree of freedom. Okay. Okay. So here we can see the degree of freedom. In this case, is actually we add these 2 degree of freedom, right, together. N1 minus 1 plus N2 minus 1. Okay? Okay, so degree of freedom is 43. And then let's say this is 1 tail or 2 tails. So this is 1 tail because we just check one side, right? And alpha equal alpha is 0.005. So we just check degree of freedom 43 and 1 tail. We just check this 1 tail 0.005. We just check that number. So that is T critical value. So let's check the T table. Okay, T table. No. Okay. So degree of freedom 43. But in the table we do not have 43. So we just check a close one, so which is 40. We just check 40, right? Okay, check this line. And so 1 tail, so we check 1 tail 0.005. So 1 tail 0.005. So check this column, right? This column. Okay, so let's say this column. Okay, so we find this number is this 1.684. So this is a critical value. So we just use this number to judge the statistic. The test statistic is big or small. Okay, so let's say 1.684, 1.684. So we just check. Okay, 1.684. So we use this as standard. Then we can find, this one is big, right? So let's say like we here 0, here the critical value is just the cutoff point of standard. Okay, so those are small, those are big. So 1.83 is big. Okay, okay. So if this is big, then we can say, difference is significant. Okay, so go back to answer the question. Can we say class 1 performs significantly better than class 2? We say yes. If we assume the values are equal, we say yes. Okay, so here we say we conducted this hypothesis testing with the assumption of equal values. So with equal values, we should use different formula, and maybe we can get a different conclusion. If we conduct testing under this assumption, we can say class 1 is better than class 2. Okay, so certainly, logically, we need to check whether this assumption is correct or true. But this is other story, right? So here we will do not go detail for these things. So okay, so we can say that if we assume values are equal, then we should use this formula for test the statistic. So here we have 2 formulas, right? So if we do not assume values equal, we use this x bar minus y bar. Okay, so then here's s1 square over n1 plus s2 square over n2. Okay, so we have 2 formulas, so don't get confused. Okay, so now let's consider some other examples. So quite the same. So let's do this problem again. Like so here we say we just need to compare two samples. Like so, for two sample, for sample one we have this information: sample size, sample mean, sample standard deviation in x bar s. And for another sample, we have this. Then we have some evidence from x bar, right? From average, we say, oh, 3.51 is larger than 3.24. Then we will check significance. Or we just check whether the evidence is strong enough. Okay, we have evidence, then check statistically, check this strength or significance of the evidence. Okay, so here let's say so such a problem we convert such a problem as testing problem. So HO is mu1 equal mu2, HA is mu1 larger than mu2. Then the test statistic. So here we have the two formulas to calculate this test statistic. We have two formulas. So which formula to use? So here let's say we say under the assumption of equal variance, we conduct the test. So if we assume under this assumption variance, equal variance, then we should use this formula, right? We use this formula. So use this formula: x bar minus y bar. So SP, so 1 over n1 plus 1 over n2. So at the first, in order to apply the formula, we need to find SP or SP squared. So by now, we can easily remember this is understand this is p square, right? So we say this is we have two variants. The other one is, let's say, two variants. Standard deviation 0.51, yeah, 0.51, so 0.52. So variance is squared. So we have those two variants. Then the polar variance is the weighted average. So weighted on what? Weighted on what? On degree of freedom. So this one's degree of freedom is n minus 1. So here n equal, so n how many size? Sample size 174. So degree of freedom is 173. So other one is 355. So degree of freedom 354, right? Okay, so this is 354. This is 173. This is degree of freedom. So totally degree of freedom, add them up. So this equal to 7 to 5, right? So okay. Okay, so with a little bit of calculation, we find the SP square, polar variance equals this, and SP polar standard deviation the same. Plug in here as the formula. SP is equal this. We just put this number to here. So we can easily get this result. So 5.65. So then we need to check for this number, so we need to determine big number, small number, so we can find critical value. But this one is this 5.65 is too big, right? So remember, like for normal distribution or standard normal, we say like for standard normal, 3 or negative 3 is big number. Okay. So if this is larger than 3, we can believe this is big. And for T tables, quite the same. Okay. So without you check the T table or Z table, we can say this number is big. Okay. Or huge even, right? Okay. So we can say the difference is big or difference is huge. And then we can say from this data, 3.51 is significant, quite big than 3.24. So we can say company A's customer certification level is much higher than that of company B. Okay. Okay. So here, so we say we do the same problem, but here only like we use different formula. If we use this, assume the values equal, then this test statistic follow exactly for T distribution with degree of freedom is n1 minus 1 plus n2 minus 1. Degree of freedom also add them up. Now add 2 degree of freedom together. Okay. So now let's consider like this problem. We have pooled variance, pooled standard deviation, so pooled meanings put together. Pooled variance, pooled mean. So we have this pooled mean, pooled variance, pooled standard deviation. Okay. So let's say if we consider proportions, we also have those pooled proportion. Okay. So now let's consider this problem. Okay. Like we want to determine who is more popular or who will win the election. So we just do 2 surveys. For candidate A, we just check 1,000 people and find 420 people will vote for him. So we can say that his percentage is 42, right? A popularity of a percentage. For B, we check 2,000 people and find 900 like B, so we find P2 hat is 45. So we have the evidence that the candidate B is more popular than candidate A. Difference is 3%, 3 percentage. So this 3 point is significant or is very big or small. So let's do those things. Let's conduct this testing. Okay. So here let's say so let's conduct testing under the assumption of equal values. If we assume the values the same, then we want to conduct the test results. So at first we say here HO is P1 equal P2. Difference is not so significant, right? So HA is P1 maybe less than P2, right? Significant less than P2. Okay, so then the question is a test statistic. we have this formula. So here we have two formulas. One is x bar minus y bar over s1 square over n1 s2 square over n2, right? The other one is this x bar minus y bar. Okay, so sp, okay, 1 over n1 plus 1 over n2. Okay, so here we should use this formula. Okay, we should use this formula. Okay, so let's say use this formula. So we need to find SP. So what is SP? So in here this is 1 0 data. So is we can say this is just a p hat q hat, right? Variance is pq. Okay, so then so here we have we have two p, we have the two p hat with a p1 hat. Okay, so p1 hat equal 42, p2 hat equal 45. Okay, so we see this SP, the standard deviation, SP is just equal some p hat q hat, right? So take square root. So the question is, we have two p hat, p1 hat, p2 hat. So which one we should choose? We should not choose p1 hat, or we should not choose p2 hat. So here we also introduce this like a port proportion. So this port proportion P, we just put P hat, okay. So equal, we just put these two candidates together, we just check how many people like them. So here we just do this, like, okay, totally we like check 3,000 people, right? Like 1,000 plus 2,000. We just check 3,000 people. So like A, like B put together. So 420 plus 900 is let's say equal 13 for 20. Yeah. So let's say we have 1320. So this one actually like this. Look here, people, we add them up. Totally, we check so many people. So like A is 420, like B is 900, right? So this percentage proportion is, we just put two survey together. We just check how many people like those two candidates. Okay, so this equal, let's say, so this equal 1, 3, 2, this equal 44. Okay, so this 44 is port proportion. Okay, so we understand the port proportion. Just put these two samples together. Port pull them in put it together, right? Okay, so we can find this tested statistic. So let's say x bar minus y bar. So we say this tested statistic is 42 minus 45. Okay, so then this is p hat q hat. P hat is 44, q hat is 56. So take square root. So this is like pooled values. Okay, so here is just multiply. So this is 1 over n1 plus 1 over n2. So this is our test statistic. So this is z value or t value. So this we say z value, right? Because the sample size is quite big, so z value, t value, no much difference. So use z value. Okay, and then so here just do some calculation, find this number. Then we need to determine this big number or small number, right? Let's say I do not, I can, okay. Let's say for this calculation, I have to use calculate, so I need to do step by step. Is okay, 0.44, 0.56. Take square root. Okay, so that's equal 0.496. Okay, so multiply. So this 1 over 1000 plus 1 over 2000. Okay, take square root. Okay, so this is 0.038. Okay, so here just a little bit of calculation. Let's say this multiply. I think is negative 1.56. Okay. So then we need to determine this is a big number or small number. So for this z value, so we have two ways we can find a p value. We also can find a critical value, right? So this, let's say this here alpha is, so by default we say alpha is 0.005, so we just check there's a 0.005 from the table, right? So we know this number is negative 1.645. So this is a critical value. So judged by this critical value, like judged by this negative 1.645, so we can find this number is small. Okay, like this number like is here, right? So we still regard it as a small number. So small number, so we can get the, so we can say, oh, their difference, 3% difference is not so significant. Okay, so we still cannot predict B can win the election. Okay, so today is a continue to the topic for two sample problem. So we finished the topic for two sample problem. So here we just check a typical situation So if we assume variance equal, then we can have exact distribution for this test statistic, right? So here we use this formula again. We have two formulas. Let's go back to here. Okay. Yeah, we have this formula: x bar minus y bar over sp times 1 over n1 plus 1 over n2. So this is p is poured variance, poured standard deviation. So we have this notation like poured variance, poured standard deviation, and poured mean, poured average. So we also can should weight the poured average. Like here, if we have two classes, class 1's average 80, class 2's average is 85. So we need to find a poured average. So average for these two classes. And for proportion, we also have a poured proportion. So we have this example. Poured proportion is just put the two candidates together, right? We have like a percentage for A, percentage for B, and a percentage for O for both of them. So this percentage for both of them is a poured percentage or poured proportion. Okay. Okay. So we finished today's topic of this two sample problem. Then next class we will move to three sample problem or many sample problems. Okay. Okay. So we can stop here. Thank you. Okay.